When we embark on a hypothesis test, we often are not sure as to what the correct hypothesis is. Here's a summary of the implications of our test decision if the null is true. The probability of making the correct decision if the null is true is 1 minus the alpha level chosen. Here's a summary of the implications of our test decision if the alternative is true. The probability of making the correct decision if the alternative is true is 1 minus beta, but calculating beta is challenging. Suppose our grocery store receives complaints that customers are waiting too long in line during the late afternoons and early evenings. If evidence suggests the population mean waiting time to have someone begin checking the customer's groceries exceeds 270 seconds, the company will need to pay for workers during these hours or risk losing customers. A random sample of 64 will be taken and the standard deviation of individual times is 40 seconds. Here is the sampling distribution used when running the test. Run the test at a 5% level of significance. With a right-tailed test and critical z-score of 1.645, any sample mean at or above 278.23 seconds will cause the null to be rejected. Let the fun begin. No, not that fun. Wow, there's a grocery store for you, but that's not ours. We need to assume the alternative is true. Beta depends on the value we choose for the alternative mean. Let's assume the mean is 540 seconds. If this is true, then all of our sample means will be way above the necessary 278 seconds. We're definitely going to be rejecting the null, and there's no chance of making a type 2 error. But what's more realistic is to ask the question, what if the true mean was only 280 seconds? Is your current test powerful enough to detect this? Visually, here's what the sampling distribution would look like if 280 seconds was the true mean and the standard deviation and sample sizes did not change. Maintaining this notion that reality is this sampling distribution, how often due to chance would we get a sample mean below 278.23 seconds, fail to reject the null and make a type 2 error? It would be a type 2 error because we're looking at the situation where the alternative was true and in particular the mean was 280 seconds. Double hypothetical thought. Using normal CDF, getting a small sample from reality that causes the test taker to fail to reject the null happens roughly 37% of the time. This is beta. The other 63% of random samples would be large enough to correctly reject the null and accept the alternative. This is called the power of the test, the probability of correctly rejecting the null if the alternative is true. The power always equals 1 minus beta, but beta can only be calculated given a specified alternative mean somewhere greater than 270 seconds, in this case 280 seconds. This is not a very powerful test, only a 63% chance of correctly rejecting the null. Here are the ways to increase the power of the test. 1. Choose an alternative mean as far above the mean of the null as possible. But this is misleading. In reality, the experts may have a key mean in mind, like 5 minutes, which is 300 seconds. They will want to know the power of the test for such a vital alternative mean. 2. Increase the sample size. It narrows the sampling distributions. Now very few of the sample means from the true distribution with mean of 280 will be low enough to fail to reject the null in the test being run. 3. Increase the alpha level, the chance of making a type 1 error. This will move the critical sample mean further left, allowing a greater number of sample means from the true distribution to correctly reject the null. Keeping this in mind, we'll do a class activity that shows in detail how these three components influence the power and probability of a type 2 error.